welcome everybody, and thank you for joining our digital Q&A session with Eddie Robinson. Before we begin, I just want to acknowledge that I'm speaking to you here from the traditional lands of the Kaurna people, and I recognise their connection to this land, waters and skies. And I pay my respects to the elders past, present and emerging, and I also extend those respects to the Aboriginal and Torres Strait Islander people here today. And I'd also like to just acknowledge the land, the traditional owners of the lands that you guys might be meeting us from today as well. So my name is Akshay. I'm a space communicator here at the Australian Space Discovery Centre here in Adelaide, and today I'm here assisted behind the scenes by Amber Pagoli. If you have any questions during our chat today, just submit them through the Q&A or ask your teacher. If you're attending from a school, to send them through for you, and then we can pass them along to our guests. So one last piece of housekeeping. Our session will be wrapping up at about 2:45 Australian Central Standard Time, but we invite you to stop into the Space Discovery Centre if you're in Adelaide, or just contact us via the contact details on our website. So our guest is Eddie Robinson. Do you want to just give yourself a little bit of an intro, Eddie?
Yeah, so my name's Edward Robinson, or Eddie. I'm the co-founder and CEO of Robinson Aerospace Systems. We're a pretty small kind of education/space startup based here in Adelaide at Lot 14. And we're doing some pretty cool things, which I'll go into more detail about very soon. All right, so I'll talk a little bit about kind of where things began and how I got to my current position. So mid 2019, probably in year 10, I believe at that time, year 10 of high school, I came across a video of a SpaceX Falcon 9 rocket landing on a ship in the ocean after putting satellites into orbit. So these rockets are like 70 meters tall, like the size of like a 21-story building, and they literally just delivered a satellite into orbit, returned to Earth, and now they're landing on a ship in the ocean. And there's a person for scale on the right-hand picture there. When I first saw this, I thought that it was CGI. I was like, there's no way that they can actually do that, land something that big after going to space. And eventually I found out that it wasn't CGI and it was actually a real thing that had happened. Right in that exact moment, it was like, okay, that's what I want to do. I want to work on rockets in the space industry. And since then, it was like, okay, how can I kind of get to that stage as quick as I can and start working on those cool things to learn a bit more. So if we go to the next slide, thank you. This led into Project Summit, which was a project by kind of like a little fake company that I called Robinson Aerospace Systems. And the goal here was to make a model rocket that worked the same way as a real rocket that would actually go into space. So this was I think it took 364 days from when I started the project to the first launch. And basically what I mean by a rocket that works the same as a real rocket is most model rockets, they use fins to try and stabilize themselves. You can probably picture a typical kind of model rocket. But this one didn't have any of that. It instead used mathematics and electronics and software to actually electronically move the rocket motor to try and steer the rocket. It's a thing called thrust vector control, which is very common. Every rocket that goes to space uses it to steer on its trajectory. So that was the primary goal of the project. The secondary goal was to make everything as kind of overkill as possible to try and maximize what I could learn. This whole thing was about learning as much as I could. So I figured the best way to do that was to just jump kind of headfirst into things, knowing that things wouldn't work, but I'd be able to fix things through a process of iteration. So what you can see on the screen right now, the rocket itself was about 1 meter tall. It was made all out of carbon fiber. Inside of the rocket was a custom designed circuit board to act as a computer, which actually took the measurements and controlled everything. It had some little landing legs you can see at the bottom to try and eventually land it like those SpaceX rockets that inspired me. That rocket is on a launch pad, which is full of different electronic and pneumatic clamps to control to hold the rocket, as well as a big briefcase flight controller to actually start the countdown sequence, just because it's really cool to have a flight controller in a briefcase to launch your rocket. So yeah, I will quickly touch on the 2 launch attempts of that project. So the first attempt, you can see to the right of the screen there, ended up in a big fire that I had to put out. So that's me, and I think I was in year 11 at the time, year 11 of high school. Basically, the one part of this project that I didn't make myself was the rocket motors, because making rocket motors at home is very illegal. It's the equivalent of making, bombs in the corner of your bedroom. You don't want to do that. So I had to purchase those from elsewhere. What had happened there is the propellant of that rocket motor had absorbed moisture, which had affected the way the motor burnt. So it burnt with a very, very low amount of power for a long time and eventually caught on fire. I fixed things nonetheless and quickly went back for a second attempt, which also failed, but this time it was because the flight computer crashed. Now, I never quite got to a third launch attempt, and the reason being is on the next slide, which is the CubeSat POC. So this was my Year 12 electronics project. The goal here was to kind of transition from rockets to satellites. I'd done a lot of research on rockets. I'd learned a lot about how they work and what's involved with them. And now I wanted to learn more about satellites. So the CubeSat POC, or CubeSat Proof of Concept, was designed to basically be the same as a real CubeSat in every way, but not actually go into space. So it's just a learning tool for me. So for those who don't know, the CubeSat is basically, it's a form of nanosatellite, which basically just means tiny satellite. So a CubeSat is 10 centimeters cubed. There's currently thousands of these in space, doing everything from monitoring weather to surveillance to running different experiments. It's really quite broad depending on who's launching it. So yeah, this was my Year 12 electronics project. Most of the CubeSat didn't work because again, I was in such early stages of learning these things. But the takeaways from that project were huge. And I was able to use the information I'd learned in future projects. The next project on the next slide, this leads me into Robinson Aerospace. So this is where Robinson Aerospace goes from the name that I was using to cover my rocketry and satellite projects into a legitimate technology startup. So just after Year 12, I had this cool idea of, okay, what if I took the CubeSat POC further and actually created a really cool product where students in high schools could actually assemble their own satellite to learn about space tech, to learn about STEM concepts, and to try and inspire more students to get into space. So what we did here is we developed RasCube, which is basically a flat-packed CubeSat. So these don't go to space, but you assemble all of the satellite subsystems, all of the structure parts, and ultimately end up with a satellite which can actually transmit data to a computer. So the way that started is I figured if I can raise some money to start developing it, then sweet, I'll give it everything I've got. If I can't raise any money, then it just wasn't meant to be. So I went all in. I kind of put all the work I could into raising some money, managed to get through that first hurdle. And yeah, since then we've made some good progress with that business. Now, to eliminate any confusion here, on the what should be the left of your screen, we can see RasCube. That is a educational product which doesn't go to space. It purely stays in the classroom. But on the right of the screen, you can see that we are actually developing one to go to space next year. So this is a bit of a side project. We're hoping in the future we can do more and more space launch stuff. So this is a good stepping stone. So the way that this project's going to work is basically a modified RasCube will go inside of a space capsule built by a European company called the Exploration Company. That space capsule will go into space on a SpaceX Falcon 9 rocket, which is that rocket that originally inspired me to get into space. So I think that's pretty cool. That space capsule will orbit Earth with RasCube on board, probably 3 times, before returning to Earth and splashing down in the ocean for recovery. So we'll actually get that satellite back. And what that means is that any schools who are using RasCube can actually see the RasCube that really went to space and make that direct link between what they're doing in class and how close that is to what actually does go into space. On to the next slide. I'll finish up here shortly. I'll hand over to questions in a minute. So here's just some cool photos of the past kind of 18 months. It's been about 18 months since I started the company. You see we've done lots of events. We've met some really cool people like the Deputy Premier up in the right corner. And yeah, overall it's been an incredible experience. I did take 1 year off of university. So I did my first semester of university last year, took a year off to make as much progress as I could. And recently I've just returned to university to keep pursuing my degree in electronics. On to my last slide, and then we'll finish up there. So every time I meet a student, I ask them this one question, which is, if you could do any job in the world for any company or organization, what would you do? Now, the reason I ask that is because I strongly believe in just following your passion to wherever it takes you. So like whatever job it is, it might not pay great. People might think it's a stupid job or you're being an idiot for chasing it. But whatever it is, doesn't matter. Doesn't matter what it is. If that's what you're passionate about and if that's what you want to do, then you should give it everything you've got to try and pursue that career in whatever industry or job that is. That ends my kind of formal presentation side, so we can start doing some questions now if you'd like. Hopefully I didn't talk for too long.
That was awesome, Eddie. Thank you. Thank you so much for giving us that presentation. I actually did have a couple of questions for you. I just, we know that the Australian Space Agency has only been formed, has only been around for just over 5 years. And your company, you said you started about 18 months ago. So how have you found that the Australian Space Agency and the space industry has grown since you've started your company, or even since you've just sort of gained interest in space?
Well, I think one of the reasons I gained so much interest in space was seeing the growth of the industry. So obviously 2019, when I became kind of interested in space, the industry existed, but it was at a very early stage. So I was kind of looking at big companies like Fleet Space or Southern Launch or Gilmore Space Technologies and kind of watching their progress. And seeing those companies actually being in Australia made it seem like it was a lot more plausible for me to actually start my own company. You think of big space companies, you think of ones like SpaceX, or you think of not a company, but like NASA. They're all overseas, but now this stuff is happening right here, and that was a big catalyst for enabling me to actually start Robinson Aerospace. And make some reasonable amount of progress in an 18-month period. As far as how the industry's grown over the past 18 months, I've definitely seen a lot more people going into it. You go to different industry events, they get bigger and bigger each year. Things like the Australian Space Forum, like every time there's a space forum, it's bigger and bigger. There's more companies there. There's more startups. There's more people. And I think that's really good to kind of directly see that enormous growth in Australia's space industry.
And how do you find it being like a young person, starting your own company? I imagine it must be difficult. There are a lot of big companies, with I guess, I'm not saying you're not good at what you do, but there's a lot of people with PhDs, like heaps of experience. How do you find talking to them, collaborating with them, and just how's your experience been a young person in the space industry starting your own company?
It's been extremely positive. You're definitely right. Like a lot of people in space, being such a technical industry, from an engineering side, which is quite a large side. A lot of people, they've got doctor in front of their name. They've got those PhDs. They've got those crazy experiences. They might have gone internationally and worked for NASA or SpaceX. They've got this crazy experience. They've got really good qualifications. And you look at me, a kid that's just finished high school. I'm currently 20 years old. I don't think I've mentioned that yet. So when you compare me directly to them, it's not very impressive. It's how can I explain it? It's been very positive in that people like to see young people doing cool things, right? Like they see someone young doing something cool and they want to try and support that and see what they can do. So like a lot of people, they're keen to kind of have a chat with me and see how they can help me and see how they can help the company grow. A lot of our earliest customers were definitely those people. When we sold the first batch of rescue kits, we didn't actually have a product. We were just selling an idea, basically. We had a very early prototype. So a lot of those early customers were people who kind of put a lot of trust in me to trust that I could actually come through and finish developing that product. Very, very positive. And as I said, people do want to support young people in the industry and try and help them kind of find their place in space.
Yeah, I think that's a great sentiment. One of the amazing things about our growing space industry is just how supportive everybody is, no matter your skill level, experience level. Everybody's always willing to just have that chat with you and provide that support where they can. We've got a few questions from the audience. So the first one is, how regulated is space when it comes to launching payloads, satellites? And are there any human factors or considerations you're evaluating when launching these satellites into space? And maybe if you want to just go through as an add-on to that question, just a little bit about what might be different between the RasCube that you're sending to space next year and RasCube that somebody could build in a classroom.
Sure. So on the regulation side of things, it is important that space is highly restricted in how things operate. So there's a lot of kind of treaties and international laws around what we can and cannot do in space. If anybody could do anything, then we'd have, space junk hitting satellites every day. We'd have, rockets crashing into places they shouldn't be crashing into. So there's a lot of restrictions around that. As far as how those restrictions relate to satellites and what we're doing, there are like licensing. We need a licensed payload to be able to launch. There's insurances around that. So, if our satellite is found to destroy the rocket for whatever reason, then whose problem is that? There's a lot of kind of legalities involved around that, which gets quite technical. I will say that honestly, I'm not an expert in that field by any means. A lot of my my knowledge is more so around the technical side of things, but there is definitely some restrictions. As for how the RasCube is going to space compares to the one that stays in the classroom, the initial goal was to keep those two as similar as possible. So the initial goal was like, okay, we would just kind of modify the electronics very slightly so that it can survive space. Now, since then, things have changed quite a lot. We're kind of trying to grab onto this opportunity of putting something into orbit as much as possible. So the electronics inside of RasCube are getting more and more advanced. We're adding some really advanced sensors. We've got a huge amount of redundancy on board, which basically means fail safes. If one thing goes wrong, then how is there a backup for that? So we've got, data is being stored in 5 different places now. And inside of RasCube is lots of circuit boards built by other people as well. So at this stage, I can't talk about most of those because they're not announced yet. But the one that I can talk about is there will be a experiment to measure radiation and radiation shielding that's being developed by an 11-year-old. So an 11-year-old named Jackson, a South Australian lad, is developing a radiation measuring payload, which is going to go inside of our satellites into space. And we think that's pretty cool that we're playing our role in enabling this young kid to send his own thing to space and back. I don't know what the youngest person in the world to put something in orbit is, but that's going to be pretty close to it. Does that kind of answer your question?
Yeah, that's absolutely amazing. 11-year-old working towards your satellite as well. That's awesome. We got another question. How long does it take to actually build the RasCube? And I guess the school program, how would that all work?
Yeah, so as far as how it's used in class, most students, so it's designed for students in year 8 to 10, though a lot of students that use it are in 11, 12. So pretty much any age of the kind of high school age group can use it. Normally it's about an hour to an hour and 15 minutes the first time a small group assembles RasCube. A small group might be between 3 and 6 students assembling a kit at once. So I haven't gone too much into what it actually does, so I'll touch on that a little bit more. Basically, students get to assemble what is essentially a real satellite. It's designed to be as close as possible to a real CubeSat. Once they've assembled it, there's a whole bunch of different sensors inside of RasCube, to measure everything from magnetic fields to acceleration and orientation and positioning, different types of generalized satellite data. So like, what might you find on a satellite in general? And that's the kind of sensors that are inside of RasCube. Once RasCube's turned on, it wirelessly sends that data to a computer where it's then displayed in our user interface software in live graphs, charts, different graphics, which basically allows students to actually run their own experiments. And they can then download that data to a Excel spreadsheet so they can actually analyze that data. So there's the assembly, there's conducting experiments, there's analyzing data, And the last point is developing their own add-ons. So inside of ResCube, for those who have done electronics in high school, it's basically a Arduino built into ResCube. So it's programmed through Arduino, which means that it's really easy for you to add your own sensors and different electronics and software to make ResCube do anything that you want it to do. So we include a lot of documentation on how that process works.
How difficult was it to get your prototype launched, or plan this launch on a SpaceX rocket? And are there any other companies that have offered this, or you've spoken to about this kind of thing?
So I've always known that eventually I'd like to launch something to space. Like from a personal point of view and from a company point of view, it just made sense to go in that direction. But when we got involved in signing on that launch agreement, we weren't actually looking for a launch provider at that time. We just got really, really lucky. So basically, I just happened to be at Lot 14 one day when somebody from the exploration company, that space capsule company, also happened to be at Lot 14. And somebody happened to introduce me to them. And yeah, I was telling them what we were doing. They were telling me about their cool new space capsule they're working on. And they just said to me, like, we're selling space inside of this for projects like yourself. It's pretty booked out, but I can talk to the engineers and see if we can fit you in. And I said, yeah, I'd be really interested in that. Couple of weeks went by. They got back to me and said, good news, we've made space for your CubeSats. This is the price involved. Is that okay? And yeah, we took the offer and decided to pursue it. Yeah, I mean, because it's a prototype space capsule, naturally the cost was cheaper than normal, which has basically enabled a very small early company like ourselves to be able to actually send something to space next year. So that whole process, there was a lot of luck involved this particular time.
Yeah, talk about, I guess, right place, right time.
Exactly.
Yeah, that's why these networking events are so awesome. I did have a couple of other questions. So how do you find it balancing, you just mentioned that you've gone back to university this semester. How do you find balancing that and also running your own space company?
Yeah, I will say that is very difficult. So yeah, I'll be completely honest with you. It is quite hard. So technically, I'm a full-time student. I'm doing 4 subjects at university, while also managing most aspects of Robinson Aerospace. Part of being a founder of a tech startup is learning how to do crazy amounts of things in a really short time period. That's kind of like, it's part of the job is just being able to do things really quickly. So when I decided to go back to university, I was like, I think I'm getting okay at doing things really quickly and managing time, so I should be okay. But it hasn't gone as well as I'd hoped, hasn't been as easy as I'd liked. So I think next year I'll probably step it back and do maybe 3 subjects at university, just to make things a little bit easier. A lot of late nights, working every single day to try and make things happen. But I mean, I love what I'm doing, so it's not really work as such. It's just following my passion.
I guess it goes back to your quote. If I could do anything, what would I want to do? So I guess looking back towards your younger self, did you ever imagine, this is where you would be? A 20-year-old CEO of a tech startup. Is that what 10-year-old Eddie would have envisioned?
My story, as I kind of went through, started when I was in year 10. So before that, I'd always loved making things. I loved Lego. I loved, at a younger age, building things out of cardboard boxes. But like, it wasn't like when I was 5 years old, I wanted to be an engineer in space. My passion doesn't go back quite that far. It was relatively new. So, I mean, I think before all of this, I wanted to be an architect. And then before that, I wanted to be the dude that drives the crane with the wrecking ball on it to destroy things. So very different things to what I'm doing right now. That being said, if I compare it to kind of more recently in year 11 and 12 of high school, watching Australia's space industry really closely, I kind of looked at places like Lot 14, where the space agency is based and where we are now, as this kind of like dreamland, you know, like all the space companies are there. It's the Space Hub of Australia, and it's an hour down the road from me. Yeah, I mean, I'd always viewed Lot 14 as a place that eventually, in 4 or 5 years after completing a university degree, I might be able to work for a company and end up at Lot 14 amongst those awesome people and companies. So to be able to be there now, to me means quite a lot. To be able to spend a lot of time around there and meet great people and visit all these awesome companies and see what's going on.
Yeah, thank you for that. It's really interesting to hear, I guess it's maybe a slightly different pathway. You hear a lot of, CEOs of space companies saying, ever since I was 5-year-old, I've always wanted to, I've looked at the stars, looked at, astronauts and rocket launches. But it is really insightful, I guess, to hear your story. How it's a little bit different, right? You've only recently sort of gained this passion for space. Someone in the chat has asked, how big are the cubes? And do you maybe want to go over what a CubeSat is, I guess the variation and what they might be, why the advantages and disadvantages of a CubeSat?
Yep. Yeah, so I'll go into, I kind of briefly touched on it before, so I'll go into much more detail. So yeah, a 10 centimeter cube. So if you look at like your average ruler, third of that, 10 centimeters, that's a CubeSat, like this big. And one of those is called a 1 unit CubeSat. So 1 unit CubeSat. What that means is we can extend these to different sizes. So a 2 unit CubeSat is basically 2 of those put together, which would make it 10 by 10 by 20 centimeters. And then you've got 3 unit CubeSats, which are even longer. You can have different kind of shapes. I think the largest one launched is a 16 unit CubeSat, which would have been 20 by 20 by 40 centimeters, I think. So about the size of a microwave. So that's the kind of size of them. They're very small satellites compared to traditional bus-sized satellites. In a lot of cases, they can do the same thing as those bus-sized satellites, just because technology has come so far that things can be so much smaller now, and so much more compact. So what CubeSats are mainly used for imagery of different kinds. So they're in quite a low orbit. They're in low Earth orbit, which is the closest orbit there is to Earth, which means that cameras don't have to look a really long distance. They're relatively close to Earth. So the camera resolution is quite good. You can see images quite clearly. So they're often used for weather monitoring or trying to monitor different gases that might be in the atmosphere, or surveillance reasons, so trying to actually take photos of what's on the ground and what's happening on the ground. Or there's the whole other side of things, which is running experiments. Those experiments could be biological experiments. So say they're trying to see how cells grow in a microgravity environment. They could be even things down to like plant experiments, put a little plant inside of a CubeSat. So they're extremely versatile depending on who's launching it and why they're launching it. So whether it's a company or a university, and what the exact goal is.
We have one that's a question that's a little bit more specific about any sort of licensing, or that you had to acquire, or is it all kind of managed by the exploration company that's launching, or that your CubeSat is going up in, or did you guys have to do anything yourselves?
So I will have to be a little bit careful what I talk about here, because there are a lot of contracts in place. But yeah, if you think about it, we've got an Australian satellite going in a European, or more specifically, German space capsule, which is going on board a American rocket. So that complicates the process quite a lot. At this stage, our launch isn't until October next year. So as far as the progress that we've made on licensing and insurances and all of that stuff, we haven't made a huge progress, just because it's not a priority right now. The priority is developing the satellite itself and getting the testing finished. However, from a agreements side, we have to have agreements with the exploration company, who has agreements with SpaceX, and a lot of the technical restrictions that we receive from the space capsule company are restrictions that they've received from SpaceX. So I hope that was clear to follow, because a lot of restrictions coming from different people. But yeah, that's the nature of putting something in someone else's space capsule who's going in someone else's rocket.
Yeah, thank you for that. I know sometimes it can be a little bit of a difficult question to answer, but yeah, thank you for describing the processes. So you've talked a lot about you know, RazCube, your company, your pathway. We were a little bit curious about what do you envision the future of Australia's space agency, or just Australia in space overall? You know, how do you think what do you think it would look like, you know, in 2030 or 2050? How do you envision that changing, especially considering, you know, the upcoming Artemis? How do you think we'll fit into that?
Yeah, I mean, Australia does already have quite a large role in Artemis with our moon rover and all the other agreements that we have in place. I can't give you timelines on things, but eventually Australia will naturally have our own kind of rocket launch company to actually launch things into orbit. And I think that's an important thing, to just have that capability, both from a competitive and a government point of view. Being able to launch rockets into orbit with Australian satellites is a pretty big deal. So right now, we've got a few people working on that, but don't quite have that capability yet, but we're getting close with that. There are a huge amount of startups in Australia's space industry right now, all with very ambitious goals. And, you know, when a lot of those start to progress to the next stages and start succeeding a lot more, we'll have, you know, a lot of satellites being built in Australia and eventually launched from Australia. Whereas right now, it's a lot of satellites being developed, but a lot of them haven't gotten to the stage of actually launching yet. So that's in the kind of near future, say 5 to 10 years. And the distant future, you know, we'll have Australian astronauts on the moon or on Lunar Gateway, eventually out to Mars and beyond. So Australia does have its role in the global space industry, and the global space industry is looking at putting humans further and further out into the solar system, and that's pretty exciting.
Yeah, you're right. It is really exciting. As a sci-fi geek myself, you know, all this stuff that we're currently working on is really cool. What do you think the biggest challenges, not just for Australia, but, you know, for humanity are, you know, as we move forward into, I guess, this new space age? Yeah, what kind of challenges do you think that we might face?
There are the technical challenges and there are the regulatory challenges. So on a regulation side, as more and more satellites go into space, the traffic surrounding Earth obviously gets more and more congested, and that brings in more and more issues. So there are a lot of people right now, even local South Australian companies, that are looking at how to fix that issue of space debris and space congestion. And there's an entire industry about space traffic management or space domain awareness of companies that all they do is track satellites to make sure they don't collide. So that's a big issue going into the future that needs more work. And on the technical side is, you know, if we want to try and have humans living on the moon permanently and on Mars permanently, and, you know, human transport in rockets for 6 months at a time, which is what it takes to get to Mars, then there's all the technical challenges that come with that. And a lot of those are around safety. You know, having enough safety involved that we can actually send humans to Mars and bring them back home is quite an important thing. And yeah, right now there's a lot of people working on that stuff again, and making a lot of progress, but we're just not quite there as far as actually being able to send humans out that far safely. So yeah, technical issues mostly around safety, and regulatory issues.
What motivated you? I guess, you know, at the start of the presentation, you mentioned that you had initially wanted to work on rockets, build rockets. You know, that may still be a dream, but what encouraged you to transition into, I guess, your other passion, which is now, you know, building educational satellites? Yeah, where did that passion come from?
Yeah, so I mean, I've always had a passion for business. When you found a startup, there's the business side and there's the technical side, right? So I've always had a passion for business. I founded a few businesses in high school. Some of them I sold to other people and used that money to start the next business. Some of them I shut down because they just weren't going very well. So there was that side of passion, which looking at that, I kind of always wanted to found a startup of some sort. And eventually it was just, getting the right idea of what that startup would be. I've always, I really wanted to start a rocket company, launching rockets into space, a rocket startup. But I looked at the economy around that, and I just didn't see it as, a good time in the market to be doing something like that. So I was looking at all different kind of other ideas, other problems that needed to be solving. And yeah, I was looking at the CubeSat POC that I developed. And I was looking at some of the current STEM statistics around student engagement in high school and the importance of STEM careers and the impact that has on the economy. And I viewed the problems around that as things that were important enough that it would be worthwhile me trying to make a product that would inspire more students. Like overseas, there are educational satellites that are 3D printed, much different to ResCube. So what ResCube tried to achieve is basically making a real satellite that we can put in students' hands, because that's much more exciting, being able to actually assemble what is essentially a real satellite. So that was the entire goal around that. And then from their passion, obviously just kept fueling it further and further.
Yeah, amazing. We have a couple questions from the audience, and I think, unfortunately, that's all we'll have time for. First of all, does the tech, I'm assuming with RasCube, need a special or paid software? And then our second question is from Izzy. They ask, is maths very important to pursue a space career?
As far as the software with RasCube, I'm not sure if that question is coming from a teacher, but when you purchase a RasCube, the price includes GST, it includes express shipping, it includes the software, it includes our lesson plans and programs, it includes all the accessories and some spare parts, all the tools, the batteries, absolutely everything is included in one price when you buy a RasCube. So no, you don't have to pay for that software. It's all included and free to access if you own RasCube. The second question with maths, that's an interesting one. So in high school, I wasn't very great at maths, and the reason being is because oftentimes I didn't see an application to the maths that I was learning. It's like they just kind of teach you this mathematics, and I memorize it for the exam, and then I forget it because I don't really see any need for it. When I kind of progressed to university, you start to see the application of that mathematics more and more at a university level, and start to realize it is actually quite important, and start to wish that you had paid more attention in class. But I mean, maths as it applies to space depends a lot on what you want to get into. So if you want to do like astrophysics and that kind of stuff, then I'd say yes, definitely. As an engineer, the maths you need is quite different. If you want to get into space law or something like that, then maths isn't such a priority. So it really depends on exactly what you want to do. Engineering and technical stuff, then yeah, you should probably definitely be paying attention in maths class. But yeah, it entirely depends on what area of space you'd like to get into.
Yeah, I think that was something really important that you just brought up, where things like space law are a career. Space jobs aren't just only limited to, an engineer or an astronaut. There are so many different things, right? Just like any other industry, space companies need accountants, finance people, business people, marketing people. So these are all real space jobs that currently exist that, you don't really need a math or science background from. So, and if you do want to learn more about space careers, you should definitely check out the Australian Space Discovery Centre, or just visit our website. It talks a lot about the different space careers you could have other than an engineer or an astronaut. Now, unfortunately, that is all we have time for today. I just wanted to say thank you to our everyone who joined the meeting. Joined the session. Thanks for listening. Thanks for asking everybody's questions. And I just want to say thank you to Eddie for sharing your story with us. It's been fantastic. It's been really interesting and insightful. And we look forward to seeing, what happens in the next few years of RasCube, and also seeing your CubeSat launch on the Falcon 9 next year.
Thank you. Much appreciated. See you later, everyone.